everyone, and welcome to this session of Google I/O 2024. My name is Benazir Fateh, and I am an AI/ML CE specialized in AI/ML services on Google Cloud. And today with me, I have Bala Narasimhan, who is a group product manager for Cloud SQL. Bala and myself are going to show you how to leverage Vertex AI for the complete lifecycle of Google's Gemini Pro language model. In particular, you will learn how to fine-tune Gemini AI on Vertex AI on your datasets, deploy scalable endpoints, and evaluate and compare models. Finally, Bala will show you how to ground Gemini and your GenAI application using Google Cloud databases. By the end of this session, you will have a better understanding of how you can use Google Cloud for building GenAI applications. So with that, let's get started. Oh, sorry. Great. So imagine that you're part of an AI team in a media company that works with Google Cloud. Within your media company, you have online newspapers that represent a core part of your business. They have enabled your company to generate revenue from various sources, such as subscriptions, advertising, and sponsored content. However, there have been some recent concerns about customer satisfaction related to one of these new online newspapers. Some web traffic statistics and customer surveys have revealed that your readers are not as pleased with their experience navigating the newspaper's website. In particular, over the last 3 months, it results that your newspaper website is experiencing a constant rise in the average churn rate. Readers, on average, are spending less than 1 minute on the newspaper articles, and the average customer satisfaction score has dropped down to 6 out of 10. All these analyses essentially say that you have a great opportunity to modernize your newspaper's website by providing more quality content and a better navigation experience. And that's why your AI lead has asked you to explore generative AI. Now, how can you use generative AI for enhancing web navigation? After brainstorming with your AI team, you agree to experiment with 2 different GenAI applications. In the first application, you would use GenAI and Gemini Pro on Vertex AI to generate some high-quality subhead summaries. The idea is that if you generate more catchy subhead summaries to summarize the article, the reader will be the reader can quickly decide if they want to read this article or not. And the second application is about building an interface for improving readers' website navigation in a more conversational way, so that you can provide direct insights into the trending news of the day to the user. As I said, you're part of this team that has just been assigned to design these 2 GenAI applications. So the question is, how do you build this generative AI application? Well, in general, when you start making a GenAI application today, there are several ingredients. There are several moving pieces in that workflow. You start by evaluating several different LLM models according to the task that you are trying to implement. You test and validate different models, you test and validate different prompts, and also different configuration for the model. You do this to identify, particularly a model to use, and also a prompt template and a configuration that works best for your decided task. Finally, depending on the generated responses and the complexity of the application, you may also need to ground this LLM responses using RAG. Or you may also want to interact with some third-party systems using AI agents. Now, what I described in words is, in general, a high-level overview of how to create a generative AI application. But in practice, it's way more difficult. It's very difficult to create a GenAI application and to put it into production and keep it running in production. So let's start from the beginning. The first challenge is about crafting the right prompt template. As a developer, in order to craft a prompt template, you seek a recipe that gets you the desired model output in a very repeatable manner. This recipe is called the prompt template. Now, as you rapidly iterate through various prompt templates, you need evaluation to identify. Evaluation will serve as your interactive assistant to identify if you're heading in the right direction, if your model, your prompt, and your configuration are correct and are giving you the desired output. Another decision you may face in this development lifecycle is choosing the best model for your use case. So a couple of models may meet your requirement, but to make a good decision, you may need to compare how they perform. Now, normally we see that all these large language models are released, and they're released with some benchmarking data sets. But then that data set and those benchmarking results show you how that particular model is doing on that particular data set, which is many a times a general data set or a standardized data set. But you still need to evaluate to see if this particular model, which maybe fared great on a particular benchmarking data set, does it do well on your customized data set also? Because summarizing a medical transcript is very different from summarizing a newspaper article. So you need to test the performance on the data that matters to you. So, and then as you find this optimal model, you might go back and tweak either the model configuration, the prompt template, etc. So let's say, after you do this, after you do this initial thing, you may ultimately, you do the evaluation, and then you ultimately realize that maybe you need more. Maybe, the summaries are good, but the style and tone of the generated summaries are not really what your readers are used to. Maybe there is a specific language that you are used to in your publication. So you can pick between tuning methods. You can tune your model. And then again, you need to evaluate that tuned model to see that the tuned model is performing better than the untuned model. Next, I have a couple of options. So once you've done this, you've tuned the model, still you may need more. You may need your model to do more. There are other options, such as you can augment the model's knowledge via an external source. And again, you need evaluation to understand if this results in a better performance or not. Evaluation is also needed to guide decisions on the design of this augmentation. As you try out different, like in your RAG system, you try out different chunking sizes, for example, for your app. And finally, once you've done all this testing and experimentation, you need to understand if you're ready for production. You'll need to evaluate on a larger data set that will cover all corner cases to see how well does the final architecture perform. And then this work doesn't end here. We all know that once a model is, or that application is put into production, there'll be new things that change. Maybe the way your user is asking or interacting with the application changes, the prompts may change. So once in production, you'll need to observe and monitor what is happening, fix mistakes, run evaluation on a larger and more automated scale, and find potential improvements. So in order to do all this and to address all these challenges, you need skills and technology. And talking about technology, that's why you have Vertex AI. Vertex AI provides a suite of services which would allow you to build both predictive as well as generative applications. Let's see how you can use GenAI services on Vertex AI for building the first GenAI application, which is the news subhead summaries generator. Let's start from the beginning. With respect to crafting the prompt template and validating different LLMs, Vertex AI provides Vertex AI Studio. Vertex AI Studio offers a comprehensive platform to develop and refine generative models. At the core of generative AI lies the concept of a prompt, which serves as a set of instructions or a simple question. Vertex AI Studio will excel in providing a user-friendly environment to design and evaluate these prompts across different LLMs by comparing them with either rapid evaluation capability or side-by-side capability. Now, you want to evaluate and compare prompts and models in your preferred IDE. This is the rapid evaluation SDK that you see for model evaluation. As you can see here, and I'll also show in the demo, what you see here is, this is the Python SDK. We also have an API for rapid evaluation. What you create is, you start with creating an experiment defining the metrics, the dimensions across which you want to evaluate your task on, and you create an evaluation task. And this evaluation task, you provide the data set, the metrics, the experiment name, and then finally you run this evaluation task. So let's see this in action. Can we switch to the, okay, great. So what you see on the screen is my Google Cloud project. And in the Google Cloud project, I am under Vertex AI. And then under notebooks, I have created a Collab Enterprise notebook. In this Collab Enterprise notebook, I have pre-created and pre-run all the cells. And so let's see all these things into action. To begin with, I have done some initial plumbing. I've mentioned what my project ID is, the region. I've created a bucket to store all the data sets, as well as any artifacts that get created in the workflow. I create a service account and provide the required roles and permissions for that service account. I import some necessary libraries, and I also created some helper functions, which will help me with visualization or just displaying all the data frame with different results. Now, the data set. So for this particular experiment, I decided to use XSum data set. So I take the XSum data set, I create train, validation, and test data frames. And I've just renamed the two columns, the content and summary, as content and reference. So reference here is the ground truth. This is the ground truth summary that you see in the XSum data set. Great. Now, the very first thing. So I decide that I will use Gemini 1 Pro 002 as a model for this experiment. I decide my temperature to be 0.1, and I configure some safety settings. And then I create a prompt template that I'll be using for this experiment. So this is a very simple few lines prompt template that I create. It'll take this article. It's supposed to summarize this article in 1 to 2 sentences. Great. And then I just do a simple test with identifying that, that Gemini Pro generates responses. And I see that I have the content, I have the ground truth reference, and then I see the summary that's generated by Gemini. Great. Now, so what next? Let's now run an evaluation experiment using, so currently we have decided on the model, the prompt template, and the configuration. Let's evaluate this combination. So I create an, similar to what I had shown on the screen. I have an experiment name, I have the model, I decide which metrics do I want to evaluate against. And then I create this evaluation task and I run this evaluation task. Now, when this evaluation task is finished, you will see this view experiment. And then it opens because it is integrated with Vertex AI experiments that will manage all the experiments that you're running. So the experiments bar can open right in the notebook, where I can see, okay, these are the different experiments, and I can see the metrics right here. But just to aid in this, just so you guys can see it better, let's take a look at this. Now here, I'm under experiments, and I look at experiments. So I can take a look at this experiment. Again, what it shows the metrics, the values of the different metrics. It shows the model name and the parameter template that I have. So great. You ran an evaluation experiment. You can see the values for different metrics. You can also in this data frame again, I also show what are the different values and also some explanations. And then finally, also let's see some visualization. So here I visualize. So as you can see, I had decided on 2 types of metrics. There were some quantitative metrics, right, like blue and rouge. Let me point to that here. Blue and rouge, and also some qualitative metrics, which would identify how good were the model-generated summaries when it comes to safety, coherence, and fluency. So as you can see, this evaluation result gave me some results. I visualized them. Great. How do I know, are these good enough or not, right? So that's what we'll cover in the next phase. But I also wanted to mention one more thing. There are many different types of tasks. Like we picked a summarization task, but evaluation can work on summarization, Q&A, tool use, text generation, etc. So a variety of tasks. And then there's a variety of evaluation metrics that you can use. And to help you with picking, like, what are the different types of metrics, one, available on Vertex AI, and two, that you can use. We also have in our documentation metric bundles. So you can see that there is a lot of different types of metric bundles that are available for you to use, pick and choose for doing the evaluation. Great. Now, can we move to the slide again, please? Thank you. So let's say that, after doing the tuning and evaluation, you found the right prompt template for generating the news summaries. But still, the tone and content of the generated subhead summaries doesn't really match with what you needed. Now, so in this case, maybe you want to consider that you can tune the model. So you may want to consider providing some reference subhead summaries as part of your tuning data set, and then tune Gemini Pro in such a way that the tuned model would be better able to reproduce the tone that you want. Now, tuning an LLM model again is very challenging in terms of there are different resources that you need to tune the model, and also again this is an entire ML workflow tuning a model. So how can you do that? Now, Vertex AI provides a service. It's a fully managed service which is called Vertex AI Tuning. This service allows you to improve the performance of your LLM in a managed and scalable way. This service is fully based on Vertex AI pipelines so that you can automate the entire tuning process, and also it will allow you to monitor it because there is Vertex AI pipelines have an inbuilt integration with Vertex AI TensorBoard. So all the training and evaluation metrics are logged into TensorBoard, and you can monitor the progress of tuning there. So to tune Gemini 1 Pro, now you can also use Vertex AI UI as well as the SDK. And what you see on the screen is an example of what the tuning SDK looks like. And we have tried to make it as simple for you as possible. So the tuning process, this is what that SDK looks like. It requires you to, of course, pass the training data set and also optimally a validation data set. Also, the next thing you'll need to define is the number of epochs and learning rate multiplier. Finally, you'll launch this tuning job that you see here, and you'll monitor its status. Let's take a look at it again in the notebook. Thank you. So, how to tune the Gemini Pro 1002 model. So again, here what you'll see is I've created some training, test, and validation data sets. I then run this tuning job. This is the same thing that you saw on screen in the deck, which is I take the source model, I attach the training data set and the validation data set. I mention epochs and learning rate multiplier. That's it. And then you can kick off the job. This is an asynchronous job. It will continue running. But then so I have already run this tuning job. Let's take a look at what this tuning job, so it will be under language, where you will see all the large language models. You will see this supervised tuning job listed there. So first things, if you go under the dataset tab, you will see that because before the tuning starts, it validates your datasets. So it'll show, okay, the training dataset had 2,000 examples and roughly these many characters in total. And then it gives you a small sample of what that dataset looks like. And also it shows some distribution. So for example, it shows the distribution of the input tokens per example and output tokens per example. So this sort of validation that it does, the tuning job does right in the beginning, it helps because, like I said, Vertex AI tuning is a fully managed service. So before the tuning job starts, it needs to identify what are the resources it needs to provision behind the scenes. So it identifies what is the size of the data set that is going to tune with. And of course, you have mentioned the model that is used for tuning. So it can easily provision the resources needed behind the scenes. And then once the tuning is in progress and the tuning succeeds, you will see different types of metrics. So you will see training metrics as well as validation metrics. Great. So we ended up tuning the Gemini Pro 1 model on the XSUM. So I took 2,000 examples from the XSUM dataset with the content and ground truth, and I used it for tuning. Now, how do I know, if this tuned model is good enough? Now, we all know that be it a machine learning model or a generative AI model, the model is going to be as good as the data set that you provide to it. So if the data set is not good, then even when you tune the model, it won't give you good results. So in this case, I know that I've used Gemini Pro 002 as a base model, and I've used XSUM for my training as a training data set. So let's evaluate this tuned Gemini model. Again, I create a test data set. I generate some summaries using the tuned Gemini. So I see Gemini summaries, I see the tuned Gemini summaries. And then I run an evaluation experiment. So again here, what you see is I have created another experiment for comparison of these two Gemini models. I have Gemini Pro, I have tuned Gemini Pro, and I use the same set of metrics. Again, a few of these metrics are quantitative metrics like Blue and Rouge. And the way quantitative metrics work is they will look at the ground truth data that you have provided, and they identify how closely this model, the model in question, Gemini Pro or tuned, how well are those generated summaries comparing as compared to the ground truth data. That's what the quantitative metrics are doing. And then there are the qualitative metrics, which is fluency, coherence, and safety. Now, in order to evaluate for qualitative metrics, we have behind the scenes an autorater model. So the autorater model is a Google proprietary model that identifies, irrespective of ground truth, how good is this generated summary. So again, I run this evaluation task. I can see this experiment like we saw before. I can also see everything in a data frame format along with explanations for qualitative metrics. I can also see them as, here I also show them how to, again, I look at a few samples here to see what the score for fluency, etc. is. But let's take a look, to get a more clearer picture, let's take a look at, let's visualize these evaluation results. Let's first take a look at the quantitative metrics. So what you see here is the Gemini Pro model. The untuned one is in blue, and the tuned model is in red. So what you see is when it comes to quantitative metrics, the tuned model does better. So, you trained this model, you tuned this particular model by giving it a XSUM data set. So it does perform better. But I do know that XSUM, sometimes, XSUM is widely used, but XSUM is a low quality data set, especially for summaries generator. And that point really shows up here, because when I look at the qualitative metrics, so when you see the qualitative metrics, what you will see is, for safety, both the models perform equally. They both provide safe summaries. But when it comes to the other two metrics, which is coherence and fluency, I see that actually the untuned version gives me a better result, but not the tuned version. So the tuned version performs slightly less better as compared to the untuned version. Why? So, remember, these two are qualitative metrics. They don't need any ground truth. They are basically checking to see, for this generated summary, are they coherent and are they fluent? The tuned version, because I tuned it on XSUM, which is a low quality data set, it ended up, for these two metrics, it ended up making the model even worse. So, this is your aha moment where you say, It's not every time. Like, it's not just that you tune a model and it's going to work better. No, that's not the case. You need to tune it, you need to evaluate it to see if it really performed better. Great. And then also I have some quantification of, how good or bad did each metric. So, we see that the blue and rouge metric improved, but fluency and coherency actually decreased by this many percentage. Great. Can we move on to the next? Thank you. So, for now, let's assume that, maybe you didn't end up going with tuning, you just ended up going with the regular Gemini Pro model. But you made a decision on which model and which prompt template and configuration you're going to use in production. Great. And you integrated them into your newspaper's web page. But now this model is in production. How can you keep monitoring the capabilities of this model? Because we all know that once something is in production, again, there are tons of things can go wrong. And you may start seeing different types of newspaper articles that get so maybe the prompt that you first decided is no longer good enough for this new types of news articles that you're seeing. Or many other factors can happen in production. So basically, we understand that once you've put your model into production, you still need to evaluate it. So Vertex AI provides computation-based as well as auto side-by-side. These are, again, two different types of evaluation techniques provided by Vertex AI. What we saw earlier was rapid evaluation. So here, I want to make one quick distinction. Rapid evaluation is something you take a few samples, you run that SDK, you get your evaluation. It's something that you do while you're doing experimentation. It's really quick. You call an SDK and you're done. We understand that you may need to do a large-scale evaluation. So computation-based and auto side-by-side metrics, they allow you to assess the performance of a model with task-specific metrics that are computed on the reference data. And here, you can provide a much larger number of samples. And the other cool thing is, both for computation-based and auto side-by-side, we have created a pipeline. Like, there's a pipeline SDK that's provided to you. So this thing you no longer have to do it in your notebook. You can run this pipeline, and you can automate it and on a much larger scale. So once your models are in production, you can schedule these pipelines, like on demand or on a periodic recurring basis. So you keep getting your evaluation results. And the other thing is auto side-by-side. What I showed you earlier was a point-wise evaluation. You define the metrics, and for each metric, you get some result. Auto side-by-side is a pair-wise evaluation. So you provide, you have a model in production, but new models keep coming. So you want to compare how the latest model that's released by Google, how is that comparing with the one that you have in production? So you can do an auto side-by-side comparison. And to run this auto side-by-side evaluation, this is what the SDK looks like. And here, as you'll see, this is a pipeline job. So all you need to do is you need to configure your training data set, your pipeline name, etc., and then you run this pipeline. So Google Cloud provides an evaluation pipeline template, and all you need to do is provide parameters. Let's quickly take a look at this one in action. Thank you. So evaluation at scale for auto side-by-side. So again, in this one, I created, now here, for auto side-by-side, again, I'm comparing two models. So I'm comparing the tuned Gemini and the untuned Gemini. The same thing that we did earlier, but I'm also showing how it can be done with auto side-by-side. So I compile the pipeline, I configure the different parameters that I need. The task is summarization, some prompt parameters, and this is my pipeline job. So we run this pipeline, and once this pipeline finishes, we'll see some auto side-by-side judgments. So what you see here, so again, it'll create an entire data frame. So you can see what the response, like for each of this content, what was the response from the tuned model as well as response from the untuned model. Great. Can you switch back to the slide, please? Thank you. So at this point, we have our newspaper's subhead summaries generator in production. Now, what about the second GenAI application that I earlier talked about? Basically, for the second one, we want to build an interface for improving the reader's website navigation in a conversational way by providing direct insights on the trending news of the day. And to talk about that, I would like to invite Bala to talk more about that use case.
Thank you, Benazir. As Benazir mentioned, what I'm going to show you now is how Simple Media can deploy a generative AI application so that their users can find personalized news articles using a chat interface. The good news is we have put together a jumpstart solution so that we can deploy generative AI applications easily. And I'm going to use this jumpstart solution today. So let's look at this jumpstart solution right now. So these are the technology components that come together to make this jumpstart solution. The link that you're seeing here on the right is where you can go to get access to this jumpstart solution as well, in case you're interested in easily deploying a generative AI application. So there are three technology components that come together to make this jumpstart solution possible. The first is GKE, where the applications will be deployed. The second is Cloud SQL for Postgres, which will act as a vector database. And the third is Vertex AI. Vertex AI will be used as an embeddings model as well as an LLM. So let's look at the various steps that you need to execute when you use this jumpstart solution. There's essentially 4 steps you need to execute in order to deploy a generative AI application using this jumpstart solution. The first is provisioning the infrastructure with best practices in place. The second is building and deploying the applications into GKE. And once you've done that, there's a chatbot that's available as part of that jumpstart solution. You're then able to interact with that chatbot. And then the fourth is basically observability, because once you deploy your generative AI application in production, observability becomes really important so that you can monitor how it's behaving. What I'm going to do now is take you through each of those 4 steps. And for step 3 and 4, I have a demo for you as well. So what do I mean when I say that you can deploy the infrastructure using best practices? Here's an example of that. When you use the jumpstart solution, we want to make security easy for you. So as you can see here, when you deploy your infrastructure using the jumpstart solution, SSL is enabled by default between the client and the server. Similarly, IAM-based authentication is enabled by default, so that you don't need to rely on database username and password. And thirdly, private IP is set up by default between GKE and your Cloud SQL for Postgres database using Private Service Connect, which makes it very easy to set up networking and makes it secure. So as far as building and deploying applications in GKE goes, there's 3 applications that come with the jumpstart solution. The first is an application that converts your Cloud SQL for Postgres instance into a vector database. The second is the chatbot that is going to run in the GKE environment, and you're able to interact with that in natural language. And the third is an application that interacts with Vertex AI, generates the embeddings, which you can then store into the vector database to run your semantic searches. So now that we've deployed the infrastructure, and then we've deployed the applications, we can look at how we can interact with that chatbot using natural language for personalized searches. And then we can look at observability of your GenAI application when it's running in production. If you can jump to the demo, please. All right, so this is the new GenAI website that Simple Media has put together. As you can see, there's a chatbot interface here. I'm thinking of going on vacation to Germany, and I'm looking for news articles about travel reservations. So I'm going to ask the chatbot to give me that. The chatbot will return news articles on that topic, taking into account my preferences. As you can see here, that's exactly what has happened. The chatbot has taken my question that I asked in natural language, identified a news article that makes sense based on my preferences. So now let's look at the infrastructure that's powering this application. This is the GCP console for Cloud SQL for Postgres, which is acting as a vector database. It's running Postgres 15. You'll see that the Postgres vector database actually has something called a data cache. A data cache is a server-side SSD that acts as a read cache. And it's able to accelerate your semantic search queries because of improved read throughput and read latency. Transitioning to observability, we have something called Query Insights. Query Insights gives you an application-centric view for observability. Here it's showing you the top queries that are running. It's giving you the details of that query. This is the semantic search query that we executed as part of that natural language question that was asked. It's going to give you information about the average execution time for that semantic search. On the right-hand side, you're seeing a visual query plan for the same query, which gives you a visual way to see the different steps that were executed when that particular vector search was run. You're also seeing that it's showing you who the top users are of the vector database, so you can understand in terms of load on the database, who are the different users that are executing the queries. And here is, again, coming back to the visual query plan, you're seeing that there was a sequential scan as part of looking up that vector index when that semantic search was executed. We also provide you a rich set of metrics so that you can monitor what's going on in your vector database. I talked about the data cache. Again, the data cache is a server-side SSD that accelerates your semantic queries. Here, there is a couple of metrics associated with that data cache. The first is the size of the data cache itself, which in our demo over here is 375 gigabytes. There's a metric that will show you that. There's also a metric that will show you that at any point in time, how much of that data cache is actually consumed. That way, you can monitor to make sure that your data cache is sized appropriately for the kinds of queries that you are running against that vector database. So you will see that right now. All right, to summarize then, what I've been talking about is a jumpstart solution that we put together that allows you to easily deploy generative AI applications using best practices, right? We provided you a link where you can go and access this same jumpstart solution, and you can deploy generative AI applications easily using that. We talked about the different technology components that form that jumpstart solution. And we showed you a demo of the observability that comes along with it so that you can run this generative AI application in production. If you can transition back to the slides, please. All right, to summarize what Benazir and I have been talking about today, we started off with a problem statement, which is that Symbol Media was facing three problems. Firstly, their users were churning on their website. Secondly, engagement on any specific news article was going down, which means there was an erosion of trust between Symbol Media and its users. As part of that, we came up with an AI-driven solution, which was to revamp the website using generative AI and make it a personalized experience for their users. And in order to enable that, we used three technologies. We used Vertex AI, we used Cloud SQL, and we used GKE. Thank you.